Hello everyone, welcome to my channel. So today we are going to do Leetcode weekly challenge. Second question: minimum time to revert word to initial state 1. So let us first read this question, then about constraint, and then finally the coding part for the same. So here let us read this question. So here you are given a zero index string word and an integer k. At every second you must perform the following operation. Remove the first key character of word, add any key character to end of string. Note that you do not necessarily need to add same character that you remove. However, you must perform both operation at every second. Return the minimum time greater than 0 required for word to revert to its initial state. Now let us take this first example. As per this question, what the first and k is equal to 3, right? So as per this question, we are required to remove the first k characters and need to append k characters at the end, which could be any, right? And then we need to check that after we have removed those k character, then whatever string which is it the same string which was there as initially? If it is not, then we are required to remove another k characters. Then again we need to check if it is the same string which was initially or not. If it is not, then again we will be removing until the whole string gets exhausted. So here we are required to return minimum operation greater than 0 because at 0 it was already at the initial stage, right? But we are required to return minimum operation greater than 0 for which we can revert the particular input string which is given to us to its initial state. Now let us take this first example. So here a, b, a, c, a, b, a and k is equals to 3. Now in this, if we remove this a, b, a, right, then we are having this c, a, b. So we removed it. Now we have c, a, b, a, and then we appended some any character at the end, right? So now if we compare with the original string a, b, c, a, b, a, right? If we compare this particular string which is there, is the prefix, basically is the prefix equals to this particular string, means any part of this particular string. Basically, if I say it clearly again, the thing is that whatever remaining string which is there after removing this particular string, means the k length string from the start, then whatever remaining string which is there, we need to check if in the original string any length prefix, if that is equals to this particular remaining string, then at that moment of time we will be simply returning that till now whatever count we have accumulated on the fact that it was not equal. Basically, see, if now here we can clearly see that this particular remaining string, it is not equals to any length of this particular original strings prefix, right? So at that moment of time we will be making our count equals to 1. Then at that point we will be again removing k length string. Okay, we removed it and now we added some other xyz characters, right? When we removed it, then we will be checking this particular remaining string which is there, means excluding this particular part, only this one, means from the original this string which is there, we will this string which is there, we will be checking that if this particular string which is there, and if we compare with any length prefix of the original string, Here, the one length prefix of original string a is equals to a, right? So at this particular moment, we got that till now whatever count was accumulated. So at the first point, the count was equals to 1. Then at the second point, because here it was also again not a match, then count became 2, right? Then when it got matched, so at that point of time, we will be returning this count. That's why this answer was 2. So basically, let me again explain you. Let us take this last example itself. So here, this A, B, C, B, A, B, and C, D. And here K equals to 2, right? So now, let us keep this original string here, A, B, C, B, A, B, C, D. This is our original string. Now first we'll remove AB and add some XY, basically same length, right? Now the remaining string which is there, right, the CB. Now we will be comparing this remaining string with the any length prefix of this particular string. And now we can clearly see that C and this A, right? So they are not matching. Then again we will be removing this and adding some XY at the end. And now we will be comparing this, but till now count is equals to 2 because 2 time it hasn't matched, right? Now we will be comparing this remaining substring which is there, right? And now if we compare for this AB, it got matched, but for C, although it got matched, but here it is B, right? So again it was not a match. So again we will be removing this, and now the count becomes 3, right? And then again we are required to check that this CD which is there, is there a match? No, it is not a match. So again we will be removing. Now count becomes 4. Now the whole string is already exhausted, right? So it is 0. And if for 0 if we match it, then surely we will be getting the match, right? Because matching it empty with a whole string, then it gives then we can easily write that string itself. And even now as we don't have any character there, right, so we can add any of the character, as it was mentioned that as a suffix we can add any character, but as a prefix we can't add any character, right? So that's why then as a suffix we can write this whole string as it is. So that's why at this point of time we have 4 as the count, and that is why it is having 4 as the count. Now if I explain you this example, A B A C A B A. Now here A B A C A B A, right? So here K is equal to 4, so that means this would be removed, right? Now the remaining string is ABA. Now if we compare the remaining string, it completely matched with the original string 3 length prefix. So that's why at the first point only it was not matched, right? So that's why here count is equals to 1, and that is how we are just required to remove just 1. And at the same point we added some XYZ here, right? And then as it was a complete match, so that's why we will be returning 1 as the answer, because here we were required to remove this. That's why the count is equals to 1. So now this was the explanation part for this particular question. Now comes the coding part for the same. So now whatever I have explained, now it is required to code this particular. So now for coding this particular, let us go ahead. The first thing is that here we will be required with a count, and you already know that why we require the count, just to check if it was a match or if it was not a match. If it was not a match, then we will be incrementing this count and n equals 2. our word which is there, word equals to word dot length. Now we will be running the loop to iterate each and every word, basically character of the string. So now if I modulo k, basically why we are doing this, so that we can remove that, we can I modulo k equals to 0. This we are doing so that we can remove till k characters only at the start. Then at the start only we are going to do count plus plus, and then basically we will be writing one function, means that matching function, because as I explained we are required to match it, right? So for that thing we will be writing a matching function which will return true or false, and on that basis only we will be returning our count. That parameters will decide later. So if that returns true, right? So at that moment only we will be returning our count. Else at the end we will be returning our count, because at the end also it is required, because if that word is completely exhausted, means if that string is completely exhausted, as in our last case where it was completely exhausted, so we were required to return 4 as the answer, which which comes after complete of this for loop. Now in this what we are going to send, now the first thing which we are going to send is our substring, the substring where we are removing the prefix of k characters. So here either it could removing the prefix of the k characters and the remaining string which would be there, that we will be sending. So now either it would be I plus k because k characters has been removed, or it would be n minus 1. As in the case of the first example, only a was left, right? So if we did I plus k, then surely runtime error would be there in that scenario. So this is a starting point in the substring, and length would be n. Now, and the second string which with which we are required to compare is the original string, as I already had shown you, because I hadn't changed its name. It is already word. Okay. Now we are required to write this match function. In C++, it is by default as private only there. So match, which will be first taking string A and then string B. Let us just reverse it, string word and string sub. So now we are required to check any length prefix of our original string. For int I equals to 0, I less than word dot length I plus plus. So if word dot length, sorry, a word dot subster, because we will be checking each and every prefix, means each and every length prefix, because prefix is always one, but how it varies is on the basis of length. So prefix, so it will be starting from 0, and this will help us to vary the length. If it is equals to our sub here refers to substring, then we will be returning true, else it will return false. So this we can write outside as well. So let us check this. And here expected is also 2. Let us check for example test cases as well. So here both are same. So let us submit this, and it got accepted. Now comes the part for the space complexity and time complexity. So here you can clearly see that it is order of n, and this whole string is basically order of n. But here this match which is there, so because of this match is also going whole word length. So that's why this particular solution becomes for the time complexity order of n square. And regarding the space complexity, it becomes here we are not using any extra space, so that's why I draw it. So this was all for this particular question, and regarding its more optimized version, we will be doing that in this particular. So stay tuned for the next video. So this was all. Thank you.